Okay, so here we have an example of the classic box and whisker plot, something you've become very familiar with on this exam. It's just a matter of knowing how to read it. What you have here is a bunch of data, and this line right here is the minimum value, or the lowest value. So they ever ask you for the minimum. They're looking for this one. There, this is the maximum value. So you have your min and your max. Here, I mean, it's not to say this line represents no data. It's just that this clump in here represents the majority of your data, because what we have right here for this line, this is always the median of your data. And the median is the halfway point, often referred to now as the second quartile. So this is Q2, or second quartile. Notice the second quartile is at the upper limit of that group. So everything below this is 50% of your data, and everything above is the other 50%, right? That's the idea of a median. It's in the middle. Now, this line right next to it here is the median of the first 50% of the data. It's called the first quartile, or Q1. So Q1, or the first quartile, separates the lower half of the data into two groups. And here, everything before the first quartile is 25% of your data. And in this interval is another 25% right here, right, between the first and second quartile. You could probably guess above the median that this quartile right here is called your third quartile. And this is the median of the larger set of data, excuse me, of the upper half of the data. So right here, this is 25%, the upper 25% of the data. So this is how these things are always set up. They always mean this, and they're usually going to ask you questions just reflecting that you know how to read this thing. So here, what they're asking you to do is look for the upper quartile. Now, the upper quartile is another name for the third quartile, and that's this number right here. Here's 80 and 90, 82, 84, 86, 88. This is 84. So the upper quartile is 84. The lower quartile, however, is 62, 4, 6, 8 right here. If they ask you for the lower quartile, they're asking you for the first quartile, or Q1. So again, this is the lower quartile, this is the upper quartile, and this is the median right here, or the second quartile, or the halfway point. And that's the basic kind of box and whisker plot question. Okay, so here they ask us, what data set describes a situation that could be classified as qualitative? Well, in data there are different ways of measuring the things you're looking at, and the comparison between qualitative and quantitative is quite important. So qualitative looks at, I guess you could say, the quality of an item. It looks at the things that you can't necessarily measure with numbers, right? So it might look, for example, I'll use a cup of coffee since, right, I love coffee. If you're looking at the taste of the coffee saying, wow, that coffee tasted great, that's a qualitative measure. But if you were to say, oh, wow, the temperature of that coffee was perfect. It was about, and I'm just taking a guess here, about 80 degrees, quantitative. And maybe that's way off, but the idea is that the quantitative measure, right, measures something that works with numbers. So maybe temperature of the coffee versus the qualitative, which looks at the quality of the coffee. So here, when we're looking for qualitative data, we're looking for something here that's not going to be measured with a number. So the first one, number one, the ages of the students. Well, that's something you can quantify with a number, so I'm going to skip that one. The test scores, that's also, right, a score, 70%, 80%, and so forth, is quantitative. The favorite ice cream flavor is qualitative, because you're not really going to put a number on your favorite ice cream flavor. You're going to say, my favorite is chocolate, or vanilla, or whatever it is, right? So that's your qualitative measure, but let's look at the last one. The height of the players. Okay, well, the heights, like if you're 5'8" or 6'2" or whatever, that is a quantitative or number measure. So here, for qualitative, look at quality. Quantitative, something you can measure with numbers. All right, so let's keep going here. Next group. All right, so we have another box and whisker plot here, and we're told that this represents the math test scores of 20 students. What percentage of the test scores are less than 72? Let's just go through the box and whisker plot again. When you have this box and whisker plot, you have these endpoints right here. This is your minimum value. the lowest value in the set. And likewise, or opposite here, this is the maximum value. And then we have the median, which is always this line in the center of the box here. The median is the middle value. And that separates things into the upper 50% and the lower 50%, right? The lower 50% is also split on the box and whisker plot. It's the median of the lower half of the data. It's the first quartile, or the halfway point of this lower 50%. What's nice about the first quartile is it separates the lower 50% into the first 25% here and the second 25% there. And of course there's a spread here in size. I mean, it literally cuts the numbers in half, but the values of the numbers might be distributed unevenly, which you can kind of tell here that they are distributed unevenly. This line over here is always the third quartile, and that just splits your upper portion of data into two groups. The upper 25% here and this 25% there, between the median and third quartile. So it essentially splits your data into four sections, right? The first 25%, the second 25%, the third 25%, and then the fourth 25%. They want to know what percentage of scores are less than 72. So let's find 72. Here's 70, here's 72. So this is your 72 mark, the first quartile. So by definition, right, this number, 72, at the first quartile is above the first 25% of the data. So the 25% of the data is below that number. Right? If they ask you below 88 here, you would say 75% of the data is below that number. If it was below the median, you'd say 50% of the data, and so forth. Okay, here we're asked what data table represents univariate data. The word uni, or one, variate data. It literally means one variable. So this might be a little difficult to think about at first, but usually it's just a frequency. For example, how many people are in your class? Well, there are 32 kids in my class. That's a frequency or a univariate measure. A bivariate, by comparison, a bivariate looks at the relationship between two things. If you were to say, what's the relationship between the number of students in your class and the average test score, right? So maybe as the more and more students, does that affect the test scores in your class? Well, that's a bivariate measure. It's usually the connection between two variables. So when they ask for univariate data, here we're looking for the choice that really deals with one variable, and that's actually choice 3. It just deals with age groups and the amount of people in the age groups. It doesn't tell you really anything about them. It just tells you the number, literally, of people in those groups. All the other ones, like this first choice, side length of a square and area of the square, well, the side length of the square, if it's 2 on each side, the area will be 4. If it's 3 on each side, the area will be 9. In other words, these two variables affect each other. It's bivariate data. And then here, the hours worked in pay, right? Obviously, well, maybe not obviously, but the more you work, the more you get paid. And that's always, hopefully, the case. Here, the number of people and the number of fingers. Well, the more people you have, the more fingers there will be around, which is kind of a weird connection, but still a bivariate connection.